Hello friends, I am Enkijan from Skill on Tech. Today we will discuss a very interesting topic, safety walls and safety relief walls and relief walls. These walls are widely used in industries for releasing overpressure and safeguard the equipment. All mechanical engineers, process engineers must know the difference between those walls, as well as they must know the internal components and their functioning. Safety wall. A safety wall is a pressure relief wall actuated by inlet static pressure and characterized by rapid opening or pop action. It is normally used for steam and air services or gas services. When a safety wall release over pressure, that is called a popping action, and that testing of that wall is called pop test. Generally, the pop test is done at a set pressure, and set pressure of a safety wall is generally 10% more than the operating pressure. Here in this picture you can see this is a inlet of the wall. So from this side pressure will be built up in the safety wall, and as you can see in this pressure gauge there is a lower pressure, operating pressure, and when this pressure increases comes to this set pressure, the safety wall will pop up and the overpressure will be released from here outlet. So this will give a popping action and a sound will come, and you can see the pressure is released, overpressure is released. So that is called pressure relief wall testing or a pop test. Relief wall, you can see a picture of relief wall. A relief wall is a pressure relief wall actuated by inlet static pressure having a gradual lift, generally proportional to the increase in pressure over opening pressure. It is primarily used for liquid service. So now you can understand the relief wall is used for liquid service, and safety wall and safety relief walls are used for air, gas or steam services. This is the difference between safety wall and relief wall. Safety relief wall. You can see a picture of safety relief wall and its internal components. A safety relief wall is a pressure relief wall characterized by rapid opening or pop action, or by opening generally proportional to the increase in pressure over opening pressure. When in air, gas or steam, the inlet pressure of safety wall, this inlet pressure increases more than the set pressure of the safety wall, it will get pop up. It may be used for either compressible or incompressible fluids depending on design, adjustment or application. But these safety relief walls are generally used for air or gas services. Conventional safety relief wall. A conventional safety relief wall has its spring housing vented to the discharge side of the wall. Means this is a discharge side and this spring is installed here, which is in the discharge side, and this is the inlet side of the wall. The operational characteristics, opening pressure, closing pressure and relieving capacity are directly affected by changes of the back pressure on the wall. The back pressure in the system is due to vent header, which is connected in the discharge side. So these back pressures are very important in operation of the safety valve, because if we will set a safety valve for a set pressure of 100 psi G, and if back pressure is 10 psi G, then the safety valve will open at 110 psi G, which is more than or higher than your set pressure. That will put your equipment under a risk. This back pressure also reduce the capacity of the safety valve. Balanced safety relief valve. You can see a picture of a balanced relief safety valve, which is different with the conventional safety relief valve. A balanced safety relief valve incorporate means of minimizing the effect of back pressure on the operational characteristics, means opening pressure, closing pressure, and relieving capacity. Opening pressure is a set pressure of the safety valve where safety valve will pop up, and closing pressure is a pressure when overpressure is released and pressure come down, then disk of safety valve come back for closing. That is called closing pressure. And relieving capacity is a how much flow is discharged through a safety valve during opening or popping action. In this picture you can see one bellow is provided here. This bellow will cover the disk of the safety valve inside of it. It will mitigate the effect of back pressure up to a certain level. These valves are generally not affected unless the back pressure exceeds 30 or 35% of set pressure. Other advantage of this bellow is it safeguard corrosion of the disc and seat. That is also very important, because otherwise, due to gases in the vent header, the disc and seat will come in contact of the gases, and that will give a corrosion to the disc and seat. Pilot operated safety relief valve. A pressure relief valve in which the disc is held closed by system pressure and the holding pressure is controlled by a pilot valve actuated by system pressure. So you can see clearly in this picture that this is a pilot valve and this is a main valve. So the pilot valve is first actuated and then the main valve release the pressure. So let us understand how pilot operated safety valve function. Below set pressure, during normal operation, the system pressure is picked up at the main valve inlet here and routed to the dome from here to pilot valve. Since the dome area is larger than the area of main valve seat, this is a dome area which is larger than the main valve seat here. The closing force is greater than the opening force. This keeps the main valve tightly closed because this area of this piston is greater than area of seat. So here there will be greater force and here it will be a less force, as force equal to pressure into area. Now you can see how PORV pop. At set pressure, the pilot valve actuated this. The medium is stopped here. Once it is actuated, medium will be stopped to going to dome, which reduce the pressure on the disc in the main valve. Here, this force will be reduced. This prevents a further rise in the dome pressure. So here, force will be reduced, hence the system over pressure to push the main valve open. This valve get open, and depending on the the pressure will be released through outlet port. Depending on the design of a pilot valve, the opening is either rapid and complete pop action or gradual and partial following system pressure modulate action. Means a partial open of this main valve seat and release of pressure here. Vacuum relief valve. A vacuum relief valve is a pressure relief device designed to admit fluid to prevent an excessive internal vacuum. In industries, there are various large tanks which are designed for vacuum as well as for pressure. The larger tanks can fail in condition of vacuum also. They can rupture if vacuum is exceeded inside of the vessel. So these vacuum relief valves are provided on the top of roof of that storage tank to breathe the air from atmosphere and break the vacuum. So these, you can see a picture of water service vacuum relief valve here. It is designed to reclose and prevent further flow of fluid after normal conditions have been restored in the tank. In industries, vacuum degassers are widely used, and that vacuum degassers you might have seen that at the top of vacuum degassers a vacuum relief valve is provided to automatically allow air to enter into the piping system to prevent vacuum conditions that could siphon the water from the system and damage the tank or equipment. Huddling chamber. You can see a picture of a huddling chamber of a safety. The huddling chamber of a safety valve or safety relief valve is the annular pressure chamber located beyond the valve seat for the purpose of generating a popping characteristics. So here you can see this is a orifice of a safety valve and this is a primary area, and this space which is shown here is a secondary annular orifice space which is called huddling chamber. So due to this huddling chamber we get a popping action in the safety valve when it reaches to set pressure. Now let us understand the internal components of the safety valve, seat and disc. A seat is the pressure containing contact between the fixed and moving portion of the pressure containing element of a valve. You can see a picture of a safety valve or safety valve with internal components. A disc is the pressure containing movable element of a pressure relief valve. So here you can see this is a disc and this is a seat bushing. This is a lower adjusting ring pin, upper adjusting ring pin, upper adjusting ring. This is a spindle, yoke, spring, lever, spring adjuster, cap. So in this cross section you can see disc and seat. This is a seat and this is a disc. Nozzle and bore area of safety valve. A nozzle is a pressure containing element which constitute the inlet flow passage. This is a primary orifice and this is called nozzle and include the fixed portion of the seat closure. A bore area is the minimum cross-sectional flow area of a nozzle. So let us understand. This is a primary orifice. Here you can see this nozzle is tightened in the threads, and this is a secondary annular orifice space which is called huddling chamber, and this is a disc and this is a seat. Set pressure and back pressure. Set pressure is the value of increasing inlet static pressure at which a pressure relief valve displays one of the operational characteristics as defined under opening pressure or popping pressure. Means at a set pressure, the safety valve will get pop up and it will relieve overpressure from the safety valve. Back pressure is the static pressure existing at the outlet of a pressure relief device due to pressure in the discharge system or vent system. Built up back pressure is pressure existing at the outlet of a pressure relief device occasioned by the flow through that particular device into a discharge system. And superimposed back pressure is the static pressure existing at the outlet of a pressure relief device at the time of the device is required to operate. It is the result of pressure in the discharge system from other sources. Overpressure, relieving pressure, flow down. Overpressure is a pressure increase over the set pressure of a pressure relief valve, usually expressed as a percentage of set pressure. Generally, the safety valve set pressure is 10% more than the operating pressure. Suppose your safety valve is operating at a 90 psi G, then the set pressure will be 99 psi G. And if pressure is over the set pressure, that will be called as a overpressure. Relieving pressure is a set pressure plus overpressure. Flow down is the difference between actual popping pressure of a pressure relief valve and actual releasing pressure, expressed as a percentage of set pressure or in a pressure unit. Generally, the flow down is 3 to 5%. So you can see in this picture, this is a operating gap. Here it is a set pressure. This is a flow down, this much, 3 to 5%. This is a reset pressure. Reset pressure is a pressure where the disc will again back to the seat and close the valve. So, and stop relieving overpressure. This is your working pressure. So generally the set pressure is more than 10% of working pressure. And this is a relieving flowing pressure. Your valve will get pop up at set pressure. And some other terms also: lift, chatter, flutter, simmer. Lift is the actual travel of the disc away from closed position when a valve is relieving. Chatter is an abnormal, rapid, reciprocating motion of a movable parts of a pressure relief valve in which the disc contact the seat. So you will hear a chattering sound. Flutter is an abnormal, rapid, reciprocating motion of the movable parts of a pressure relief valve in which the disc does not contact the seat. That is called flutter. Simmer is a audible or visible escape of fluid between the seat and disc at an inlet static pressure below the popping pressure. When the internal pressure is increasing and it is trying to reach at the set pressure, but just below the set pressure, when it reaches to the set pressure, the disc will start to lift, and that is called simmering. At that time, a slow leakage starts of pressure releasing. The popping pressure, and at no measurable capacity, it applies to safety or safety relief valves on compressible fluid surface. Application of safety valve, relief valve, and safety relief valve. So you can see here, these are the applicable fluids. Compressible media, safety valve are used for compressible media, vapor and gases like steam, air. Opening is by pop action or sudden opening. Code requirement is ASME section 1 and IBR. Operating gap is 5%. Flow down is maximum 6%. Application utility and industries. Overpressure is 3% of set pressure. And relief wall is used for incompressible media or liquids. Opening is proportional to the excess pressure over the set pressure. Designed by Section 8, ASME Section 8. Operating gap 10%. Blow down 15% maximum. Application petroleum and fertilizer industries. And overpressure is 25% of set pressure. Safety relief wall act as a safety wall in compressible media and act as a relief wall in compressible media. Means it can work in both pop action in compressible media and proportional opening in incompressible media. Design code is ASME Section 8. Operating gap is 10% minimum. Blow down maximum 15%. Application all application except boiler drum, SH and RH. Overpressure is 10% of set pressure. So these are the important applications of safety wall, relief wall and safety relief walls. Thanks for watching the video. If you like this video, hit like button below, share it with your friends and colleagues, subscribe our channel for getting updates on upcoming videos. Please leave any comments, feedback to improve the videos. Thank you.